In this video, I am going to explain 3 things. I am going to explain why all ionic compounds are electrolytes, the information found within a net ionic equation, and how to predict the formation of precipitate in a double replacement reaction. Ionic compounds are held together by ionic bonds, and when ionic bonds are placed in water or any other polar substance, they break apart. For example, if you drop some salt in water, the electronegative oxygen molecules form a circle around the positive sodium ions. The hydrogen ions form a circle around the chloride ions. This happens for every ionic compound because every ionic compound has a positive and a negative side. This dispersal into cations and anions into a polar substance makes all ionic compounds electrolytes. Now I'm going to explain the information found within a net ionic equation. Net ionic equations show the ions that actually participate in a chemical reaction. It is a portrayal of a chemical reaction that gets rid of the spectator ions. For example, NaCl aqueous plus AgNO3 aqueous goes to NaNO3 aqueous and AgCl solid. If we break this apart, we get Na plus aqueous plus Cl minus aqueous plus Ag plus aqueous plus NO3 minus aqueous goes to Na plus aqueous plus NO3 minus aqueous plus AgCl solid. Now if we cancel out the like terms on both sides, we get Cl minus aqueous plus Ag plus aqueous equals AgCl solid. What are you doing, Aaron? Now I'll explain how to predict the formation of a precipitate in a double replacement reaction. First, you carry out the double replacement reaction and identify the products. If one of the products has NO3, C2H3O2, ClO3, or NH4, or a group 1 element, then it is automatically aqueous. If there is an SO4, let's just look at the car. I don't even know who that is. Then it is aqueous. If there is an SO4, then it is soluble, unless there is a calcium, barium, strontium, lead, mercury, or silver, or as Mrs. Fishel says it, kabosopog. If there is a Br, I, or Cl, or bromine, iodine, or chlorine, it is soluble, unless there is a Pb, lead, Hg, mercury, or Ag, silver. If there is an OH, an SCO, a CRO, or a PO, it is soluble, unless there is an NH4 or a group 1 element. Now I'll give you an example. NaCl aqueous plus AgNO3 aqueous makes NaNO3 aqueous plus AgCl solid. NaNO3 is aqueous because it has a group 1 element, and it also has NO3. AgCl is solid because there is a chloride, but it is paired with the silver, and a chloride is insoluble when paired with the silver. Okay, I stop it.